Okay, we're back here. In this video clip, I want to take you through really an overview of the course. There's a handout. It's available on the course website, so if you don't have that printed out or maybe just get it up on the screen so you can see it while you watch it, it'd be helpful to follow along. You don't have to. You can just sort of get a sense of what we'll be doing in this course, assignments, etc., etc. So on the handout, first thing or near the top, you'll see, besides my information, is the quote from Einstein we ended with last time. So let's just remind ourselves about that one more time. The important thing is not to stop questioning. Curiosity has its own reason for existing. One cannot help but be in awe when one contemplates the mystery of eternity, of life, of the marvelous structure of reality. It is enough if one tries to comprehend only a little bit of this mystery every day. And certainly one of the goals for our course is if you want to be more of that type of person, we will try to lead you through to a deeper understanding of this special theory of relativity and some of the implications it has for how we think about space and time and some of the weirdness that comes about because of that, the strange things it predicts and strange paradoxes. So first thing, just to, you can, if you have the handout, you can see the course description. Again, we're trying to understand Einstein. So you might ask, what does it mean to understand Einstein? Is it partly understanding his scientific ideas? That's certainly true. But it's also understanding where did those ideas come from? What was Einstein himself like? How did it all come together in the so-called miracle year that we mentioned last time in the first video clip? So our goal, as it says here, is to go behind the myth-making, beyond the popularized presentations of relativity. Some of you may have read those articles and perhaps books and maybe even seen videos or documentaries and things like that. And they can give you a good basic understanding, idea of what this is all about. We want to go deeper than that. We want a deeper understanding of what this is all about, what Einstein was all about, what these strange paradoxes and predictions are in terms of the theory. So some of the questions we'll address: how did Einstein come up with his ideas? What was the nature of his genius? What is the meaning of relativity? What's special about the special theory of relativity? Why did the theory initially seem to be dead on arrival? It was not universally acclaimed as a great breakthrough at first. What does it mean to say that time is the fourth dimension? You hear that all the time, maybe in science fiction circumstances and so on. So what does that really mean? Can time actually run more slowly for one person than for another? And the size of things change depending on their velocity, their relative velocity. Seems ridiculous that something like that could happen. Is time travel possible? And if so, how? I'll give you a heads up. The answer is yes, in certain circumstances. Time travel is possible, and so we'll explore that. Why can't things travel faster than the speed of light? You've heard maybe of speed of light as a universal speed limit. Well, why? What would happen if something went faster? Is it possible to travel to the center of the galaxy, which is about 30,000 light years away, and return in one lifetime? Again, that would seem preposterous because if it's 30,000 light years away, 1 light year is the distance light travels in 1 year. So it takes light, a beam of light, 30,000 years to get there. And even if we could go as fast, therefore, as that light, it seems like 30,000 years it would take us to get there and then back again, maybe another 30,000 years. We'll find that it's a little stranger than that, actually. Is there any evidence that definitively confirms the theory, or is it just mainly speculation? Why didn't Einstein win the Nobel Prize for his theory of relativity? And other questions as well. So those are some of the things we'll be looking at. So if any of those really grab your attention, grab your curiosity, then again, this would be a good course for you. A little bit about me there. You can see, like I mentioned in the first clip, I'm an academic director at Stanford. My background is I have a PhD from UC Berkeley in the history of science. Also have a master's degree in physics and another master's degree in interdisciplinary studies and sort of philosophy of science and so on and so forth with that. So before coming to Stanford, I taught for a number of years at UC Berkeley and also UC Davis, not only history of science and history of technology, but also some engineering courses, computer science, and things like that. But that's beside the point, because that's not what we're covering here in this course. Okay, prerequisites for the course. This course is open to anybody. It's open to the general public. In terms of knowledge, you just have to have a curious, open mind and also the desire to really think about things a little more carefully than perhaps we usually do. You'll be asking also, is there any math involved in this? In fact, Stephen Hawking, the great theoretical physicist who suffers from wasting disease, so he's in the wheelchair, has published a number of bestsellers, sort of has taken over as an icon of science in many respects from Einstein, in earlier years. He, in his one of his best-selling books, he was advised not to include any equations, because for every equation you put into the book, he was told, your audience will be cut in half. And so we could certainly teach the special theory of relativity without any equations, but again, we need to go a little deeper than that. Out of it. So those are some of the prerequisites. Required materials. You have to buy anything for this course, and the answer is no, you don't have to buy anything. All the material, or nearly all the material, all the required material certainly, will be either done via video clips or via handouts. We will be, for one of the assignments, actually looking at Einstein's original paper on the special theory of relativity. That wasn't actually the name of the paper, but we'll look at it. It's surprisingly readable. There is some math in it. We'll skip over those parts just so we get a general sense of his argument. That's available online. There will also be one recommended reading on a profile of the young Einstein that I wrote and published via Amazon Direct Publishing, and we'll talk more about how you can access that. It's relatively inexpensive, $2.99 U.S. currency, or depending on where you might be around the world, whatever currency is your local currency, they're the equivalent in that. So we'll talk more about that at a later time. But that's really, those are the outside materials. We'll need the original Einstein paper available online, and not required, but a recommended reading. So if the $2.99 is a burden for you, and it very well could be, or for whatever reason you decide not to read that, that's fine. Again, it is recommended but not required. For the course, let's take a quick look at the course outline, where we're going. So again, it's in your handout here. We're sort of in week 0, as it were, of the 8 weeks. This is the introduction phase. So we did a video clip on why take this course. This video clip is the overview of the course. The next video clip will be how to succeed in this course, giving you some tips to help you understand the material better, actually in this course or any course. We'll have a little bit on the rules of engagement, especially in discussion forums and for the course in the online website. And then a quick math review for those of you who want to look at that. So that's the introductory part. Then, okay, we said 8 weeks. Week 1, we'll look at Einstein in context. Every week we'll have Einstein quotes of the week. We'll say a few words about those, give us some things to think about perhaps. And then we'll have a thought experiment to think about. We'll do a couple of those throughout the course, in addition to our engaging the brain, priming the brain type questions. 2 main things, however, we'll look at in week 1. We want to look at physics circa 1900. What was going on in physics about 1900 when Einstein was working on a special theory of relativity, or some of the ideas around that up until 1905. And then what was Einstein himself doing around 1900, 1905? What was his life like? So we won't spend a whole lot of time on that, but we do want to get a better understanding of Einstein, the person, that all of this was not just happening in some vacuum where he was sitting in a room someplace thinking great thoughts and writing stuff down on paper, equations and scribbles and things like that. So that's week 1, Einstein in context. Then we'll turn more towards the basic concepts of the theory, and want to really spend some time laying good foundations. We don't want to jump into this too quickly because even though these are simple basic notions of time and length, it can be very easy to get confused with these things, as we'll see later on. So we'll talk about what is an event in space and time, how do clocks factor into this, what role do they play, what's this idea of a reference frame. And so this is when we'll actually look at his June 1905 paper, which was entitled On the Electrodynamics of Moving Bodies, whatever that means, but essentially was his Special Theory of Relativity paper. And again, try to lay the foundation for some of the key concepts we'll be using there. And then look at Einstein's starting point. He actually developed this theory based on two postulates or principles. He said, we're going to take these two postulates as true, and in fact, as we'll learn, they seem to be contradictory. And in fact, that was a stumbling block for Einstein for a long time. He looked at this, he said, yes, this is true, this principle is true. He looked at this one, he said, yes, this principle is true. But clearly, they seem to contradict each other in certain ways. And he couldn't overcome it until a friend of his actually gave him a key insight as they were walking and talking one day, perhaps during lunch, during the lunch break at the patent office. This friend also worked at the patent office. The next day, Einstein came back and said, I've got it. And later he said he realized that time was suspect. Time was suspect. And so we'll definitely be thinking about that, what that means, and what was his breakthrough. Then in week 3, we've titled that Ethereal Problems and Solutions. This whole notion of the context, why was Einstein having such problem understanding what was going on here? Why were other people having problems understanding what was going on with the so-called luminiferous ether? It's the medium by which light waves were presumed to travel, just like water waves travel through water. If light was a wave, as was well understood, then it must travel through some medium as well. And that medium was known as the ether, or in fancier terms, the luminiferous ether. So we need to have a little understanding of what does that mean and what were the implications and why were people puzzled by trying to put all this together. So we'll look at a couple famous experiments. One, the Michelson-Morley experiment. Another experiment involving so-called stellar aberration. And just try to get an idea of what's that all about. And then some of the solutions that people came up with before Einstein actually came along and just sort of took a whole different approach to the problem. So that's laying the foundation. Then in week 4, the weirdness begins. And this is where we take Einstein's two postulates, his two principles, and say, okay, they seem contradictory, but let's take them both as true and see where we end up. And that's what he did, and that's where he realized that the notions of length and time they're not, in reality, they're not our common sense notions of how they work. So time is suspect, length is suspect, simultaneity, that two clocks can be simultaneous or two events maybe. Two clocks can be synchronized, and therefore events can be simultaneous to one person, to another person who's moving with respect to those clocks. The clocks are not synchronized, and events are not simultaneous. So what's simultaneous to one person may not be simultaneous to another person. Clocks that are synchronized to one person will not be synchronized to another person. And this really called into question the fundamental notions of space and time that people had held for centuries. So we'll look at that. And we'll look at some of the actual experimental evidence that this is not just some wild speculation, but it actually is true in the real world. Then in week 5, we've entitled that Space-Time Switching. We'll develop actually something called the Lorentz transformation. It's a mathematical tool that will make our lives easier when we're trying to figure out some of the issues and problems that we encounter in dealing with the special theory of relativity. We'll talk about the ultimate speed limit, why the speed of light is an ultimate speed limit. Then in week 6, we'll talk about, well, maybe can we break that ultimate speed limit? Is it possible, and what would happen if we break that ultimate speed limit? Week 7, we'll get into more paradoxes to ponder, including the famous twin paradox you may have heard about, where the idea is if you send somebody off in a spaceship at very fast velocity to another star system, and then they come back again, the theory seems to predict that if they're identical twins, that's why it's called the twin paradox, if one goes off and then comes back again, they will be younger than the twin who stays home. And yet it's like, well, isn't it just as far as the person in the spaceship, don't they just see the other twin going away from them and coming back again? Maybe they have their own spaceship, if you imagine two spaceships. So here's one. So one goes off this way and comes back. The other one goes off that way and comes back. It seems to be equivalent. What's going on there? Is it really true that one would be younger than another? So it seems like it's paradoxical. So we'll investigate that paradox and a few other paradoxes as well. And then week 8, to conclude, to the center of the galaxy and back. That notion, we introduced it with a question earlier. Could you actually travel to the center of the galaxy and back again in one lifetime as an astronaut on a spaceship, assuming we had a spaceship that could travel fast enough? So we'll look at that. We'll also come back to Earth in a sense and look at the reception of relativity. Why wasn't it universally acclaimed when Einstein first introduced it? Why was there a lot of skepticism, even derision? The president of the American Academy of Science actually said something to the effect that no one believes this garbage, that anybody could believe that time is different for one person than another person, or lengths change if you go at a fast enough speed, and so on and so forth with that. We'll look at Einstein's Nobel Prize, why he didn't win it for the theory of relativity, have some thoughts perhaps about the nature of genius, and then think about relativity beyond science, how it's used in popular culture, have a few words about that. So that's an overview of the course, and again, all the details are in the handout. In the next video clip, we're going to look at some tips on how to succeed in the course, or really any course that you might be taking.